Hello and welcome to Morehouse's Math Menagerie, where outliers are always welcome. Today, we're going to be talking about a confidence interval for two independent means. Mr. Barnes is interested in estimating the difference in the mean ski race time for two courses. He took a sample of skiers from both Course A and Course B. The data is summarized in the table below. We are being asked to construct a 94% confidence interval for the difference of the mean ski race times for the two courses. We are first going to define our parameters. Let mu sub A equal the mean race times for course A, and mu sub B the mean race times for course B. This is a two-sample t-interval for means, and we are doing mu A minus mu sub B. There are random samples of 35 and 33 racers respectively. The central limit theorem applies since both samples are at least 30. And the 10% condition is met. It's reasonable to believe there are more than 350 high school racers on course A and 330 for course B. My apologies for the error on my slide. Now, we could first use the formula to find the confidence interval. Here we could subtract the means from the two separate samples, x bar sub A minus x bar sub B. This would be our point estimate. We could then say plus or minus our margin of error. And this margin of error formula is pretty intimidating, so let's break it down. This first value up front here, the 1.9499, is our critical t-star value that we found using the t-distribution. We then have the standard deviation of race times for A, the sample for A squared, divided by the sample size, plus the square of the standard deviation for race times for course B, divided by the sample size for course B. Doing all that math, we get this lovely interval here, negative 0.2604 to 0.7204. This is a lot of work, and I wouldn't necessarily expect you to use the formula to find this. So let's jump over to Desmos and see how we can do it there. The first thing I'm going to do in Desmos is open up my inference menu, and we're doing a t-test since we're doing two means. It asks here, first off, for our sample data. Well, we don't have our sample data, we have the summary statistics. So I'm going to select stats, and I'm going to type in my sample size of 35. The mean, which was 6.78, and the standard deviation of 1.13. I'm then going to add my second sample, which had a size of 33, a mean of 6.55, and a standard deviation of 0.94. When I clicked create test, then it brings it to my menu here where I could do either a significance test or a confidence interval. Since we are doing a confidence interval here, I'm going to do a drop down that menu here. I'm going to put in my confidence level of 94%. And you can see here I now have my interval negative 0.251 to 0.711. These are slightly different than what we found using the formula due to rounding. To complete our problem, we are then going to interpret our interval by saying that we are 94% confident that the true difference in the mean race times for course A and course B are in the interval negative 0.2514 to 0.71144. Thank you for joining us. I'll leave you with this quote by Shah Rukh Khan. Have a great day.